We're talking about everything that has to do with nicotine addiction in the brain.
That's right. New ways to possibly treat nicotine addiction, new studies, more about pain. Man, there's a lot to cover.
Let's dive into it right now
On Smoke Break.
That was really natural.
Yeah.
So nicotine addiction and GLP-1s, what's the deal here?
The scientists were curious whether this new class of drugs called GLP-1s, which is typically used for diabetes and weight loss, could maybe treat or help people who want to quit nicotine.
And what exactly is a GLP-1?
So they're medications that are natural hormones, and they're involved in things like appetite and metabolism, but they also influence the brain reward pathways. And that's how they relate to addiction.
How does this change the way we think about solving nicotine addiction?
Well, it really expands our approach. It's interesting because GLP-1s affect the reward pathways that give us dopamine. Might be kind of a new way we could treat this, which is really novel and new.
So is there anything we truly learn from this going forward?
The biggest takeaways we have is that these GLP-1s could dampen nicotine reward and help control withdrawal symptoms. But so far, the strongest evidence is in animals, and human results are promising, but they're not yet conclusive.
Well, it sounds like this could possibly lead to something good in the future.
Yeah, absolutely. It's still very early, but there's promising results. So hopefully in the future, we have new treatments for people who want to quit nicotine.
Well, next topic. Nicotine and pain. It seems like they go hand in hand. What did we find out?
This was an interesting study because for a while, clinicians have known that people who have quit nicotine might seem to be a little bit more sensitive to pain, and they're curious why that might be.
So what did they actually find out?
So people who recently quit smoking were more sensitive to pain, and they found that they needed more pain meds after surgery. They also looked at their brain scans, and they showed that some areas involved in managing pain and stress weren't working normally while they were in nicotine withdrawal. So basically, quitting smoking temporarily changes how the brain processes pain, and that makes everything hurt more.
Sounds like a lot of really bad stuff. I mean, does this really matter in the long term?
So there were a few limitations, like weaknesses in this study. So there's a couple things to keep in mind. Only men were tested, so we don't know if women would have the same brain changes. Also, it was a very small group. It was just 60 people, so bigger studies might find more. It was only one type of surgery in one hospital, and the study doesn't prove cause and effect. So it does show a connection here, but we can't say for sure that the brain changes.
What it sounds like you're saying, it's just pain receptors in the mind is what's really tricking the person into thinking they're feeling more. Not necessarily that it's causing more pain, it's just the mental aspect of it.
Yeah, so there's a few important areas of the brain that weren't working at full strength. So these are the areas of the brain that usually help calm the body down and control pain. So withdrawal puts the brain into this state where pain feels stronger than usual.
So what's really the public health takeaway on this situation? Is there something that people should know if they're smoking right now?
The big message is this: quitting smoking is still absolutely the right choice. But when you quit, especially right before a surgery, your brain might be a little bit more sensitive for a while. And so that doesn't mean don't quit. It just means that we should support people better before they do quit. So if you're a hospital or a doctor out there, it might mean you should expect that recent quitters may feel more pain. We should believe them and plan ahead so they can get the pain relief that they need. For the public, it just means that what you're feeling during withdrawal is real and it's happening in your brain. It's not any sort of imagination.
Whoa, this fire's getting kind of big.
Yeah. Whoa!
Let's start this one off with what we know.
Okay.
Nicotine addiction impacts the brain.
Absolutely.
Now, originally we thought it was just neurons.
Mm-hmm.
Now we're hearing that it's more than that?
Yeah, there's a recent study that came out that wanted to understand why nicotine creates such long-lasting impacts in the brain. And they looked at specific cells within the brain.
Of course, you're baiting me into it. What did the research show?
We usually blame neurons, right, for this nicotine addiction, but this study zoomed in on a different kind of brain cell, a cell called an astrocyte. And they wanted to see if astrocytes actually play a role in addiction. And it turns out they do. And it's a pretty big deal.
Wait a second. What actually is an astrocyte?
Right, so astrocytes are these star-shaped cells. They typically, like at least what it was taught to me, they're support cells of the brain. So for decades, we've treated them like background workers in the brain. They clean up chemicals, they keep the environment stable, and they support neurons. But this study actually shows that they're key players in how the brain responds to nicotine.
So how did researchers find this out after all this time?
They did animal studies. So they looked at rats and they gave them doses of nicotine and watched what happens inside the astrocytes. And so what happened is it actually caused this funny little spike in calcium, and that set off this chain reaction of events. And it basically revved up this glutamate system. What's glutamate, you might ask? Glutamate is the brain's go signal. And when this glutamate signal speeds up, it strengthens our habits and our reward systems. And here's the wildest part of this whole thing, is that when researchers then blocked one step in that astrocyte pathway, the rats showed less of that addiction-like behavior. And that's a very big deal.
I guess the big question for me is, did this change any of our philosophies toward addiction?
Honestly, yeah. So for years, we've told a very neuron-focused story about addiction. But this study says that that picture is actually bigger than we might have thought. It's about the communication between neurons and glial cells, like astrocytes. So it reinforces something that's been getting clearer in the science, and that's that addiction isn't a moral failure. It's not this lack of willpower. It's a whole brain adaptation that involves multiple cell types working together. And so I think this pushes us more toward a nuanced, a more compassionate, and biologically accurate understanding of nicotine dependence.
So where do we actually go from here?
Well, we start asking the big questions. If astrocytes play a role in nicotine addiction, do they also influence alcohol, opioid use, or other substances? And maybe we can design treatments that target these glial pathways or prevent the brain from forming these long-lasting adaptations in the first place. This is the launch pad for a whole new direction in kind of addiction science.
So is there a public health angle to all this?
So this helps us explain to people that quitting is hard because nicotine literally rewires the brain for addiction. And it rewires it on multiple levels. But it also shows that the more we understand, the more tools we eventually have to help people quit for good.
It's getting dark outside. I think we should wrap up.
I know, Nala wants to go home too.
Well, if you're interested in these articles, they're going to be down in the description in case you want to check them out yourselves. But until then, I think we'll catch you on the next episode out there in Smoke Break.
That's right. And if you want to see more of Canine Nala, you can see her on Nala Tracks. And yeah, she goes and likes finds Rico.
We'll catch you on the next one.
Bye. Okay, Nala.